Welcome to another episode on my driving the robot Discovery based on the fischertechnik TXT controller, running embedded Linux and programmed in Python, and equipped with two front sensors, active sonar, USB camera for use with OpenCV, and a propeller in the back to indicate that the algorithm is running, at least from a certain point. I had prior to recording a problem. I did an experiment for an oncoming fischertechnik event, and to see if that worked, I tried to connect to a different wireless access point. Although I did manage to, I got no connection. So checking whether I could connect using the devices I always use, I found that I had a very big problem reconnecting to the old device, and after finally managing that, I found that the IP address had changed. I find that very odd, but apart from that, I could not even, through the menu, correct the IP address that I always use. So what to do? And I figured that I could maybe do it through SSH. So using the ifconfig -a command, I figured out which it had, and that was similar to the one I found in the menu on screen. But fortunately, I was able to through SSH to alter it. So that raises a question: what will happen when I am at that event? I have to do it again, to try again, of course, and then I will properly record my attempt. For now, I'm happy to be back with correct IP address. And despite the address, the password never changed. So, otherwise I could not even get in there, not in a proper way. Anyway, right now I am back to where I started, with a distance of 40 centimeters, give or take. So, let's see if it is willing to run after I clean up the mess from last time, which is rather important. So I'm removing the remainders of last time, which is done now. And then starting the algorithm, see whatever it can come up with in speed, and if it goes like lightning, just like that, or that it gets step by step like last time as well. Always a surprise. It shouldn't be a surprise, but it is. And that's what I mean. Step by small step by small step, and even like last time probably. Ooh, okay. And now you see that. Okay, now something that I noticed right now. This gear was running full speed, motor wasn't. And the problem, see, that's what I mean. So, pulling back a bit, now wait what is happening. Oh, never mind, that was it. So I have to do this again. After I look at the images. But yeah, let's look at the images first, because I wonder what that is. Alright, so let's first look at some imaging. 1, 10, 4 and 0 and 141. Alright. Now I am wondering, oh wait, 160, then 38, this is, unfinished business. Alright. Then I need another one, 14, 36, 38, what is 141 anyway? Close between 6 and 10. Alright. Actually not quite alright, but 4 is right in the end. What is 10 again? Ten is contact. Right. Because it bumped into the objects. Oh, then I can just as well use that one. Oh, that may be an interesting one. Which is 36, 44, 10. Oh, that grey as well. 45 then, 50, no, 52. Alright, how do I see red in here? Using HSV. Oh, that is not too bad. However, I have one in at the start, so 60, 31.1. And of course the image. Which comes before this one. Logically. And that is less impressive, I have to say. So let's do this again. From a distance of, important, okay, 35 something, and it fails, totally fail. What is the battery condition right now? 8.4. Yeah, well, that is logical, because I used the battery as well when I did that other network test. So I have to be careful here that it doesn't drop really below 8, because past experience has shown that it just goes. In other words, shut down, power off, or power off without shut down, which is even worse. Right, let's increase the distance a bit here, and let's see whatever happens. if something happens. Yeah, camera said, okay, let's go. Okay, it's just errors. Okay, next. Propeller, 0. One, that's good. Oh boy. And now also the gear goes. Right here the gear was running like so, bit by bit. Yeah. Right, I cheated, but here's a 20. A 20 after a cheat. And a 14 with another light. But the basic thing is, and I have to check that, how come does that red gear run freely over the axle with that wheel? Okay, first of all, let's check, because I had a 20 and a 25 as well. Interesting. 41 is of course earlier than, hey, wait, 10, 14, 44, 41, 25. Alright. Go. And here it already, okay, so this image in the results should be black. Yeah, well, with some white, but it is black. So, okay, now for the 20, yeah, for the 20, 48, entirely black. Probably because it hit the big case. No. Okay. Nothing at all in the image. Oh wait, I should change this because this is image. Oh right. This is probably the case. It's grey, so the case, not black. Right. Any other specific thing? I have a 15 as well, which is even later. So 45, 15. What is this? Also, okay, then the other one will be black as well. So of no interest actually. But 15, where's 15 anyway? $15 is between 4 and no, yeah, between 4 and oh, smaller than 4, right? And yeah, that's 15. Right. Now I have to check why that gear goes on. Alright, taking it. So actually this is the gear from the motor. Then the motor goes on, and this is a special gear that that has a flat axle in it, or a flat end, and this one is also flat. So this means actually that while the wheel is standing still, the whole axis turns with it, because the motor turns, the motor runs, the black gear runs, the red gear runs, and it drives the axle, and only the wheel stands still. And probably on this other side as well. Interesting thing to notice. But then again, another question is, why does it act this way? Because what I want is to run relatively slowly, and then pause while an image is being taken, and that is certainly not happening now. So let's get up in the code. 10 and 12, and this is 12:15, this is 15:20. So yeah, here speed is 250. Here the speed is still 125. Here too, 125, right here. Here it is 125. Now I am getting here at, alright, 250. So let's reduce that. And oh, here it is even 512. Let's just absolutely reduce this. Oh, yeah, this is easier to do. And here too, 125. And before the battery is gone, let's save it. Okay, here it's 128, doesn't matter. It's a very close distance. So with this set and done, let's do another test, and hopefully with less speed. Go. And by the way, the distance is about 30 or 45. Oh, come on. What is this? Keep going. Oh wait, that is to say, what is the battery voltage? Yeah, right. Okay, battery check. 8-ish. Okay, then I really should prepare for a battery change before things go really wrong. But let's do one test. And this is not a test where I can use an AC adapter. So it is time to change battery. Alright, battery changed, and now this newly charged battery was 9 volts, has already declined. And I think the reason for the very fast decline is that it also reached the battery voltage from software, which it should. Anyway, let's hope that the new speed does go on. And this is 30 to 45. What happened here? See, that is a disadvantage of Python. I have made a mistake here, and now it comes across this if statement, and only then you can find the error. So I have to replace this. After which, yeah, this is alright. This is alright. This wasn't. But I'll have to start again. And hopefully get it done at exactly the same time. So this is 40 and it stopped at 30. So it does not measure these objects, it measures this. Nice experience. Let's start again. Although the angles are like this, but 30 was for that one, and now it goes wrong. Waiting for it to stop, I can abort it, but yeah, let's do that. Right. Yeah. 30. Very good. 20. Very good. And the 20 is because of that 13. $131. Very nice. And this is basically what I wanted to happen all the time. Small pieces, small parts. Although this is 131 too many. What happens now with the gear? With this gear, it wanted to turn around and it didn't, it quit. Okay, and you can see it with this, turn to the left at a distance of 9 centimeters. To where exactly? Well, probably this object, 9 centimeters. Oh, and an error name. Oh, once again, not defined. Okay, so be it for now. But I have some very nice new stuff, which means I have a 141. No, that's old. 15. I have 0, I have 30, 20, 13. So 15 to let's go for 30, right? This one. What is the result? Not good. Alright, next. It's 29. No, 19 actually. Oh wait, I already had that. Then let's skip to 34. And what should it be in image? Okay, next. 13 is 41. And next is, of course, the result. I'm not impressed. I am not impressed. Then we have 49. Which was after a very short distance and very short ride. No, I'm disappointed in this. Very much disappointed. So this is most certainly not what I had hoped for. No. Then this is the best result. And at a very close distance, as you can see. Yeah. No. Right, last part, saying goodbye. Thanks for watching. Results, as I've said, not what I expect. What did help was reducing the distance by mostly half, or well, in any way reducing to 125. That helped, but too many questions left. For now, thanks for watching again. If you like this video, please subscribe to my channel and get many more interesting robotic and embedded system stuff, because this is both a robot and an embedded system. Please like and if you want to leave a comment or suggestion. You can follow me on Twitter. Please retweet, like, and leave a comment. You can also follow me on Instagram. Please like and leave a comment. You can also support the blog, and please do so by making a small donation either by PayPal or Wired. More information on my website. You can also choose to become a patron and have your name mentioned as a supporter. Also, please see my website for more information. This is going to be continued. All mentioned options, including my website, are at the start of this video and under this video. So, once again, thank you for watching. This is to be continued.